Hi, everyone. There are some questions that I've received from some students that I think that it's going to be better for me to go over and then post it on Blackboard so that all of you can watch and then review it. If you're having problems with any of these questions, I think there are two of them for now. You could always go back and then look at it again, especially uh, because they are in the homework and then also they might be on the quiz. So if you've already done the homework, you've done the quiz, that is fine. But of course, you could use it in the exam. So that is also good. Now, the first thing I have to talk about is that please, if you are going over the practice problems and you are having any problems with the question, if you're having any challenges solving the question, please, down here, there is a send to instructor button here. I've circled it in blue. Hit that and then send it over to me. I'm going to receive it by email. I'll look at it and then try and then help you solve it. I would solve it or give you some steps to solve it and then send it back to you. So please use that. There is also the tutor session there. Click on it. It's going to give you a step-by-step solution. It's going to give you a hint. It can also take you back to learn. And all these would help you understand or know how to solve the problem. Now, quickly, let's look at this first one. So here we have potato chips, which is 22.5 cents per ounce. So from what we've done so far, we know that this is 22.5 cents per ounce, which means per 1 ounce. Now, this is a unit rate, right? Because the denominator is 1. Now, let's keep going. If a bag costs $2.99, how many ounces are in the bag of chips? So the whole bag is $2.99. How many ounces? Let's do X ounces. Again, if you look at what I did, you could clearly see that I have set up a proportional equation. I've got the money on top and then the ounces at the bottom. And that is how you should set it up. Now, at this point, there is a problem. What is the problem? The currencies are different. I've got cents, I've got dollars. So what I should do at this point is that I could either change the cents to dollars or change the dollars to cents so that I would have the same currency here. So if it's cents, it should be cents for both of them. If it's dollars, it should be dollars for both of them. That is what I mean. So to do that, I am going to change the $2.99 to cents. How do I do that? To change $1 to cents, you multiply by what? 100. So you have 100 cents or 100 pennies. So if $1, equals 100 cents, then $2.99 is going to give me $2.99 times 100. And you can put this in your calculator. But because we are multiplying this by 100, 1 times 2.99 is 2.99, right? And then because we have 2 zeros, that allows us to move the point 2 times to the right, 1, 2. So this becomes 299 cents. So this is going to give us 299. I mean, if you don't know how to do that, put it in the calculator. But always, when you have the number of zeros, especially when you have one, like 100, 10, 1000, any number, of course, multiplying one or being multiplied by one is that same number. So you add the zeros by moving the point to the right. If you are dividing, you move the point to the left, depending on the number of zeros you have. So here I have 2.99. So I could change this proportional equation. And what am I going to have? 22.5 cents over 1 equals 299 over x. So now I have cents on top, on both sides of the equation. Now I could cross multiply at this point. When I cross multiply, I'm going to have 22.5 x equals 299 times 1. Of course, that is 299. Now, for x to stand alone, I divide by 22.5. I divide by 22.5. I cancel out. So x equals, now I put this in the calculator. When I do that, I'm going to have 299 divided by 22.5 equals 13.2888. Now, this is in cents, right? This is in cents. Remember, I changed the dollars to cents. So this is in cents. Now, if the problem tells you, I mean, this is in cents, but the x here is ounces, so that's fine. So we keep it at that. So we have x equals 13. Now it says that to the nearest what? 100.29. Why? Because to 100 we are looking at this point, and then 8 of course is greater than or equal to 5. It's greater than 5, so we add 1 to that that number. That is the 100th digit here. So we do that. All right, so we have 13.29 ounces, and that is fine. Okay, so that is how you deal with these kinds of problems. Remember, our x here is in ounces, so that is right. Now, we could also have a question where we have to find an amount, and that is what I was thinking that this one is, but it's not. Again, make sure you set up your proportional equation. If you set up your proportional equation right, then you are almost done with it. Please, if you have any issues about this, send me an email or let's arrange to meet. As I already told you, please set up some office hour time with me and I could help you. If my office hours do not fit your schedule, that is fine. Send me a message. Let's find a time that would be convenient for both of us. Okay, it doesn't matter if it's night time or whatever. I really want to help all of you, so let me know. Let me know. All right, now let's look at the other problem. Let's look at the other problem, and that one is going to be this one. So I'm going to erase all these and then look at this one. So in this problem, we have a recipe, right? A recipe of chocolate chip cookie. Now, the recipe makes 2 dozen cookies right here. But you need 3 dozen cookies. You need 3. But the recipe is for 2 dozen. Now, in this recipe, for the 2 dozen cookies, it says that you require 1½ cups of sugar, 3 teaspoons of salt, 1/3 cups of pecans. So how much of these ingredients are necessary for 2 dozen cookies? So with this problem, again, you have to set up a proportional equation. Let's first start off with the cups of sugar. And this is when the integrated review homework is really, really important for you to, look at, because the integrated review homework takes you back to changing fractions from improper to mixed numbers or mixed fractions. So if you look at this, if we are looking at sugar, we know that 1/2 is for the 2 dozen cookies. We know that, right? But what I need is for 3 dozen cookies. I don't know the amount, so I have to find that. So again, to set up a proportional equation, there are a couple of ways to set this up. But with what we've done so far, you should see that you could do this. 1/2 cups of sugar divided by 2. That is the 2 dozen cookies, right? So that is the rate. Now we have to set it equal to another rate. And what is that going to be? We have 1/2 cups of sugar. This is going to be X cups of sugar over 3 dozen cookies, right? Because what you need is the 3, and we want to find how many cups of sugar. Now, at this point, you could cross multiply, or you could multiply through by the LCM or the LCD. Now, let's cross multiply. If you do that, you have 1/2 times 3 equals 2 times X, which is 2X. Now, how do I change from mixed numbers to improper fractions? So I have 1/2 should be equal to 2 times 1, which is 2, plus 1, which is 3, and then the denominator is still the same thing. So 2 times 1 is 2, plus 1 is 3, so 3/2. So I'm going to have 3/2 times 3 equals 2X. Now 3, I could do 3/1, right? Any number over 1 is still the same number. So again, with multiplication, you go this way and then you go that way. So 3 times 3 is 9, divided by what? 2, because 2 times 1 is 2. I don't have space, so I'm going to erase this part. If you are writing, I think you should pause it and then, or go back and then write it down. So I'm going to have 9/2 equals 2X/1, something like that, right? Okay. Now I could either cross multiply again or multiply through by the LCM, LCD. 2 times 1 is 2. So I could multiply through by 2. So 2 times 9/2 equals 2 times 2X/1. Again, you could cross multiply. Now 2/1 here, 2 would cancel 2. I have 9/1, which is 9, equals what? 2 times 2X is 4X. Now remember, 9/1 is 9, so I could divide through. But let me erase this and do it here. Let's see what I have here. So I could do, remember 9 equals 4X, 4X equals 9, it's the same thing. So I would do, 4X equals 9, it's the same thing. I divide through by 4, I divide through by 4. So X equals 9/4. Can I simplify this fraction to its lowest term? No, it's going to be 9/4. Now to change to a mixed number, X equals 4 goes into 9 how many times? 4 goes into 9 how many times? 2 times, because 4 times 2 is 8. So it goes into 9 2 times. And then because 4 times 2 is 8, I subtract 8 from 9. I have 1 remaining, a remainder of 1 over 4. The denominator would always be the same. So it means that for 3 dozen cookies, my cups of sugar is going to be 2 cups and a quarter. 2 cups and a quarter. Now I have to do the same thing for the salt. So let's go to the salt and look at that also. Let's go to salt and look at that also. Let's go to salt and then look at that. All right. So for salt, for the 2 dozen cookies, I mean the recipe, we had 3 teaspoons of salt for 2 dozen cookies. So divided by 2. This should equals X or Y, any variable is fine, divided by 3 dozen cookies. I could erase this because we know what I'm doing here. So I could erase this and then do that. So again, I could multiply through by 6. Why? 2 times 3 is 6. That is the LCD, right? The LCM or the LCD. So I could multiply through by 6. If I do that, I'm going to have 6 times 3 over 2 equals 6 times X over what? 3. Now 6 is 6 over 1. 2 goes into itself 1 time. It goes into this 3 times. 6 over 1. 3 goes into itself 1 time. It goes into this 2 times. So in the end, I'm going to have on top, I have 3 times 3, which is 9. 1 times 1, which is 1. So it's equal to 9. 2 on the other side, I have 2 times X, which is 2X over 1. That is fine. I divide by 2. I divide by 2. So what do I have? X equals 9 over 2. Now, converting this to a mixed number again, please, these are in the integrated review. Go look at them, okay? I know that it's been a long time for many of us. So please go back and then look at them. Take your time and then go through them. Again, 2 goes into 9 how many times? 4 times. 2 times 4 is 8. If I subtract that from 9, I have 1 left over 2, like that. So it means that I'm going to use 4 teaspoons and a half, 1/2, 4 of salt for 3 dozen cookies. And then the last one, I'm not going to do that because at this point we should be able to set it up. Again, if you have any questions about this, send me an email. Thank you, and I hope you do well in the quizzes and then also on the homeworks. Thank you, and have a great weekend.